Alright, the quadratic formula is a nice formula that will help us to solve quadratic equations. The quadratic formula says that if we have a quadratic equation that's in standard form, where it's ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You will have to memorize this formula. You will definitely have to know it. But let me show you how to use it. If we have the equation x squared plus 4x minus 45 equals 0, it's in standard form, and the leading coefficient is 1, the linear coefficient is 4, and the constant term is negative 45. That means that a is 1, b is 4, and c is negative 45. And all we need to do to solve this is to plug those values into the quadratic formula. Well, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need to plug in these values. So going through the equation once again, x equals negative b plus or minus the square root of b squared minus 4a times c all over 2a. So we have an expression, and now it's just a matter of calculating it. 4 squared is 16, and negative 4 times 1 is negative 4 times negative 45 is positive 180 all over 2. So we're at negative 4 plus or minus square root of 196, which is 14. So negative 4 plus 14 divided by 2, or negative 4 minus 14 divided by 2. Oops. So we finish it up. Negative 4 plus 14 is 10 over 2 is 5, and negative 4 minus 14 is negative 18 over 2 is negative 9. And there's our two solutions for x. Let's do it a couple more times. First of all, we might end up with a situation where it's not in standard form yet. So to get it in standard form, here we're just going to add 9 to both sides so that we get it equal to 0. This is real important. We have to have it equal to 0 and in standard form so that we can identify that a equals 25, b equals negative 30, and c equals 9. Now we can plug things into the quadratic formula and start solving them. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So now we got a whole bunch of numbers in here. Things might get big, but that's okay. We can let our calculator help us out. First of all, the opposite of negative 30 is just 30 plus or minus the square root. And we could probably just type all of this into our calculator. Make sure you use parentheses so you're not taking the opposite of 30 squared, but you're actually squaring negative 30. And you'll end up with an interesting result that we get 900 minus 900, and everything underneath there ends up just being 0. Then down in the denominator, 2 times 25 is just 50. So we have 30 plus or minus 0 is just 30 over 50, which is 3/5. So this one will only have one solution. One more time. Negative x squared plus 4x minus 5. First, get it in standard form. So negative x squared plus 4x minus 5 equals 0. So then we can see that a is negative 1, b is 4, and c is negative 5. And then we just plug it into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then get to simplifying. Negative 4 plus or minus the square root. And it looks like 16 plus 20 is 36 all over negative 2. So negative 4 plus or minus 6 over negative 2. Negative 4 plus 6 is 2 over 2. Or negative 4 minus 6 is negative 10 over negative 2. And our two solutions we see are negative 1 or 5. The discriminant is a special part inside of the quadratic formula. It's actually just this piece that's underneath the square root. And if we look at the discriminant, we can find out a little bit about our solutions without actually having to solve the whole thing. See, the thing is that if the discriminant, b squared minus 4ac, is positive, if it's greater than 0, then we'll have two real solutions. Because we'll have a positive number like 9, and so we'll have to take whatever that negative b is, plus 9, or plus the square root of 9, and minus the square root of 9. And that's how we'll get two different real solutions. But if that discriminant is equal to 0, then that's like how we had with our second example when we were adding or subtracting 0. So we're going to take negative b plus 0, which is just the negative b divided by 2a, and negative b minus 0, which is still the negative b divided by 2a. So we end up with only one unique real solution. And finally, if that discriminant, b squared minus 4ac, is negative, then we have a problem, because we're trying to take the square root of a negative number. We'll still have two solutions, but they won't be real anymore. Now they're going to be imaginary. So if we're trying to take a square root of a negative number, just like before, we're going to have a number that has I in it, so it won't be real. So let's use the discriminant to determine the number and type of solutions to the equation. So what we want to look at is b squared minus 4ac. Right, and for this problem, that's going to be 4 squared minus 4 times 2 times negative 4, which is 16, and then plus 16 times 2 is 32. So that equals 48. Since that's positive, that means when we are dealing with the quadratic formula, we're going to take the square root of 48, which is a real number, and we'll have plus or minus that, so we have two real solutions. And that's all because 48 is positive. For the second example, we would need to get it in standard form first, so subtract 9x and add 11 so that we get it equal to 0. Then find b squared minus 4ac, which is going to be negative 9 squared minus 4 times 8 times 11. 81 minus 352, which leaves us with negative 271. So if we were doing the quadratic formula, we would have a square root of a negative number, which means we'll have two imaginary solutions. All because that 271 is negative. So all we really care about when we look at the discriminant, is it positive, is it negative, or does it equal 0?